Water, simple, transparent, and seemingly ever-present, is the foundation upon which life on Earth stands. Yet behind its familiar shimmer lies a profound cosmic riddle. How did our planet, once a molten sphere of rock and fire, become adorned with vast oceans, rivers, and clouds? To truly appreciate the story of water's arrival, we must journey back in time, to the very beginnings of our solar system, and trace water's path across billions of years. A story woven from dust, fire, ice, and the restless movement of the heavens. Nearly 4.6 billion years ago, the sun was born from a swirling cloud of gas and dust known as the solar nebula. As gravity pulled this material together, clumps formed, some growing into the planets we know today. Earth began as just such a clump, its surface a tempestuous cauldron of molten rock, bombarded relentlessly by asteroids and comets. The early planet was inhospitable, its atmosphere thick with carbon dioxide, nitrogen, and sulfurous gases. Temperatures soared, making the existence of liquid water impossible. No gentle rain fell, no rivers carved the land. Only fierce volcanic eruptions and cosmic impacts shaped this primordial world. As Earth cooled, the question emerged: was water always part of our planet's makeup, or did it arrive from afar? Scientists have long debated this, and today, two main theories guide our understanding: the endogenous or internal origin, where water was present from Earth's very formation, and the exogenous or external origin, where water was delivered by cosmic messengers from the depths of space. According to the endogenous theory, water's story began within the very dust and rock that coalesced to form the planet. The solar nebula was rich in hydrogen and oxygen, the essential building blocks of water. Some minerals, known as hydrated silicates, carried minute amounts of water locked within their crystalline structures. As Earth formed and began to cool, volcanic activity raged across its surface. From deep within the mantle, gases, including water vapor, were released in a process called degassing. This steam billowed into the air, thickening the atmosphere and, as temperatures dropped, condensing into clouds. Eventually, rain began to fall, possibly for thousands of years, gradually filling the lowlands and giving birth to the first primitive oceans. Yet while this internal process contributed to Earth's water, it may not fully account for the sheer volume present on our planet today. This is where the exogenous theory steps in, painting a picture of cosmic delivery on a grand scale. Beyond the orbit of Mars, in the cold, dark reaches of the solar system, icy bodies, comets and asteroids, drifted through space. Comets, in particular, are icy time capsules, composed largely of water ice, dust, and frozen gases. For a long time, scientists imagined that as these comets bombarded the young Earth, they delivered vast amounts of water. While this idea is alluring, studies of cometary water revealed a twist. The ratio of hydrogen to its heavier isotope, deuterium, in most comets does not match the ratio found in Earth's oceans. Attention then shifted to a different kind of space rock: carbonaceous chondrite asteroids. These ancient relics from the inner solar system contain hydrated minerals and, crucially, have a hydrogen isotope signature much closer to that of Earth's seawater. Unlike comets, these asteroids would have struck Earth more frequently, and their impacts would have brought water in a form more readily incorporated into the developing planet. The leading theory today is a synthesis. Earth's water came from both within and without. Some was released from the mantle by volcanic activity, while much was added later by asteroid impacts. The timing of this delivery is vital, and evidence points to a period known as the Late Heavy Bombardment, around 4.1 to 3.8 billion years ago. During this era, the inner solar system endured a barrage of impacts from asteroids and comets. Geological clues, such as ancient zircon crystals, show signs of water-based erosion dating back over 4 billion years, suggesting that liquid water was already shaping Earth's surface soon after these cataclysmic events. But receiving water was only half the battle. For Earth to become the blue planet, it had to hold on to its precious cargo. Several factors made this possible. Earth's size and gravity are sufficient to retain a robust atmosphere, unlike smaller worlds such as Mars, which likely lost most of its water to space. Our planet's magnetic field, generated by its churning metallic core, acts as a shield, protecting the atmosphere from the erosive force of the solar wind. And importantly, Earth orbits the Sun at just the right distance, the so-called habitable zone, where temperatures allow water to remain liquid for much of the planet's history. Recent discoveries have added fascinating new chapters to this story. Analysis of lunar rocks and Martian soil reveals that water, in some form, exists beyond Earth as well, hinting at a solar system-wide process of delivery. Even more remarkable, studies suggest that vast quantities of water may be locked deep within Earth's mantle, trapped inside minerals like ringwoodite. This hidden reservoir could contain as much water as all of our oceans combined, slowly cycling between the deep interior and the surface through volcanic activity over geological timescales. The origin of water on Earth is not just a question of planetary science. It touches on the very origins of life itself. Water is the medium in which life's chemistry unfolds. Understanding how Earth acquired its water guides our search for life elsewhere. If water can be delivered by cosmic processes, then the conditions for life may be common throughout the universe. Distant exoplanets, circling other stars, may also harbor oceans awaiting discovery. In the end, the story of water is a story of cosmic alchemy, a tale of elements forged in ancient stars, of dust and ice wandering the solar system, and of a planet uniquely suited to nurture life. Every glass of water, every drop of rain, is a testament to this extraordinary journey. Water is not just a substance. It is the memory of the universe, a reminder that our own origins are inextricably linked to the stars. So next time you watch the rain fall or feel the cool touch of water on your skin, remember, you are experiencing the legacy of a miracle billions of years in the making. A miracle that turned a fiery world into the living, water-rich Earth we call home.